Hey guys, welcome back. We are going to go through some transformation examples today. And the first question we have here is a word transformation, and we're going to see how that has an effect on the equation itself that we're transforming. So we have y equals e to the power of x reflected in the x-axis, dilated by a factor of 2 from the y-axis. So this is important. Look at your keywords. This is from the y-axis, shift to left, followed by a shift down of 4 units. Okay, so first step, we always start off with equations. So f of x becomes negative f of x. If you're reflecting in the x-axis, that has an effect on the y value, which occurs outside the function. So that becomes negative f of x equals, we're going to apply that to the original function, which is e to the power of x. Therefore, you get negative e to the power of x. Next step, dilated by a factor of 2 from the y-axis. So the first thing I look at is, it's from the y-axis. What happens here? It affects the inside of the function because it is to do with the x value. So that becomes f of, we have to take the reciprocal, which is half x. And now all you're doing is subbing this x value with the half x. So you get negative e to the power of half x. Next step, shift to left by 2 units. Once again, affecting the x value inside the function. Left means you're going this way, which usually means minus, so therefore it's x plus 2. So when we use null factor law, we can get a negative 2 translation. Therefore, once again, sub it in, negative e to the power of half, sub that x value with x plus 2, followed by a shift down of 4 units, affecting the y-axis. Therefore, it becomes f of x minus 4. It has to do with outside the function. And all you have to do is sub it in. Okay, that's first question. Now, the second one is we have the equation and we want to describe it in terms of word transformations, okay? So, describe the transformation that has been applied to the graph of y equals 1 over x in each of the following examples. You're starting from 1 over x, and then you change it into 2 over x minus 3 plus 4. So, we'll start with dilation. We always follow the order, Dr. T, which is dilation, reflection, and translation. So I can see the most obvious dilation is 2 times the whole function. So we have dilate a factor of 2 from, since it's timesing the whole function, from the x-axis. So what we're doing essentially is we're doing f of x equals 1 over x. And then what it becomes is we are applying 2 f of x, so it becomes 2 over x. Now, the next step, reflection, but there's no reflection either because there's no negating occurring in either the outside of the function or the inside of the function. So obviously we move on to translation. The most obvious one here, inside the function, that means it has an effect on the x-axis. Oh, not dilation. Translate 3 units to the right. So what is occurring here is if we use null factor law, x minus 3 equals 0, you get x equals 3, and this is positive, therefore it is moving 3 units right on the x-axis. And if we take a look at this, you have f of x minus 3, and all you're doing is subbing that in, which is 2 over x minus 3. And then you have to translate 4 units up the y-axis. So you have over here, you have f of x plus 4, and now you've basically got the original function again, okay? I mean, the function that we're supposed to find the transformation of. So this is not necessary for the steps, but I'm showing you how the word transformation is related to the equation. Okay, next step, once again, we're starting from 1 over x and we're transforming it to get this. So the first step, obviously I'm going to expand it, which gives me, so 1 over x, we're turning it into 3 over half, x plus 2 plus 3, because you're timesing out each term, okay? Now, first step, obviously following DRT, you have to ask yourself, where's the dilation? Very easy. There's 3 here. We say dilate a factor of 3 from the x-axis. Second dilation, there's 1 here. So we have dilate a factor of half from the y-axis. And if you said that, you get an angry face. No. And you might be thinking, why? Well, once again, you see this dilation has an impact on the inside function, okay? It's where the x is. So what I'm supposed to do is, you're supposed to take the reciprocal. So what it should be is 2. Now, reflection is only reflection? No. So you move on to translation. Now, here's the hard part. Let's do it in the x-axis first. So that is to do with the inside of the function. So you have half x plus 2. Remember, to find the translation, you just use null factor law. Make it equal to 0. And you solve and you get -2, -4. Therefore, this tells me this is a translation of 4 units left on the x-axis. Okay? Because you move this to the other side. Okay, I'll just do it. You get half x equals -2, x equals -4. Okay, so that's how you figure out the translation. And then obviously the last one, very simple, it's just a +3 outside the function. Therefore, it is translate 3 units up x-axis. Now, there is another way of doing this though. So what we have here is 3 over half x plus 2 plus 3. If you are good with dealing with functions and the different forms, you can realize what I can do is write this in a different form. So I can take out, so write 3, and then if I take out half from both of these, right, plus 3, what I can do is I can cancel out these two numbers. So 3 divided by a half would become 3 times 2, which is 6 over x plus 4. So I'm changing the form of it. And now, if I write down the transformation, it's going to be a bit different. So starting with the dilation, I have dilate a factor of 6 from the x-axis because it's outside the function. Second step, just translate 4 units left because I have x plus 4 and I make that equal to 0, which I get -4. And then I have translate 3 units up. So what I've done here is I've essentially cancelled out, if you look at the pink, I've cancelled out the dilation to get one dilation just from the x-axis, okay, which is an outside of the function effect. Now, from the sequence of transformations, find the image of point 2,4 after it is applied. Okay, so you have to first tell me what the word transformation is based off of this. Once again, follow DRT. I can see 1/3 is timesing the outside function. So I have f of x, it becomes 1/3 of f of x. So this is dilate a factor of 1/3 from the x-axis. Now, what else do I have? Once again, look for another dilation. There's a 3 in front of the x. That's to do with the inside function. And once again, if you're doing the inside function, that's from the y-axis, right? Dilate factor. And now the factor changes. It's not 1/3, 3, because it's inside the function. And remember, when you're doing inside the function, you have to take the reciprocal, which is dilate a factor of 1/3 from the y-axis. Now, what else is there? Is there a reflection? Yes, there's a reflection in here. If you look at the green, inside the function. That means, there's a reflection. If it's inside the function, obviously this is a reflection in the y-axis. And that has an impact on the x value, which is why it's in front of the x. Now, let's look at the translation. So, just use null factor law, -3x plus 6 equals 0. Your translation, you move that to the other side, that's -6 over -3 equals 2. So you translate 2 units right on the x-axis, and then for your y, you just translate 4 units down. 4 units down the y-axis. Now, how does this impact the coordinate? So let's show you the transformation on the coordinate step by step. And you always have to go from the word transformation to show the impact on the coordinate. We start out with our first step. We're dilating a factor of 1/3 from the x-axis. This means it has an impact on the y value. So you just times 1/3 with the y value, which becomes 2, 4 over 3. Now, dilate a factor of 1/3 from the y-axis. This means you're changing the x value. So you just times it by 1/3. So you get 2 over 3, 4 over 3. Now, reflection in the y-axis, so you're changing the x value. So what happens is that it becomes negative 2 over 3, 4 over 3. And then translate 2 units right on the x-axis. Once again, you just plus 2, so that becomes 4 over 3, 4 over 3. And then you have translate 4 units down, you minus 4 from the y value, that becomes 4 over 3, negative 8 over 3. And this is your new coordinate of the image. So these are some examples, and some of them are quite difficult, so make sure you understand step by step. All right,